Implementing collaborative robots or cobots can be an effective way for manufacturers to get started with automating tasks and reducing the physical workload on their employees. But effectively integrating automation technology such as cobots often requires specialized hardware, and 3D printing can help. I'm Stephanie Hendrickson with Additive Manufacturing Media, and at MPE, the Plastic Show 2024, I learned more about how 3D printing is assisting with robot and cobot integration. At the event, I met with automation technology provider Universal Robots and their partner EMI Corporation, which provides robot grippers and other types of automation integration products. What I learned is that it's relatively easy to incorporate a cobot into a workflow these days. These robots are relatively safe, they're easy to train, they're easy to move around the facility, but the difficulty comes from the way the cobot is going to interact with its surroundings. So how is it going to communicate with the different machines, and how is it going to interface with the parts that it needs to handle? That's where 3D printing comes in. At EMI, they 3D print many different automation products, including robot grippers and end effectors, part nests and fixtures, even things like cable management brackets. In the Universal Robots booth at NPE, they had this demo running. There was a Universal Robots cobot using a 3D printed vacuum gripper to lift a set of parts as if they had just been removed from an injection molding press, place them into another 3D printed fixture designed to cut off the sprue material, and then lifted that set of parts again and placed it down on a conveyor as if those parts were going on for additional processing. All of the fixtures used in this demo were 3D printed by EMI. The company routinely 3D prints tooling like this using multi-jet fusion, typically out of nylon. They also use TPU for parts that need to be handled delicately. Sometimes they'll even thermoform a flexible material over the nylon to provide a non-marring surface for handling parts like lenses. EMI finds that 3D printing custom automation tooling like this is cost-effective and keeps lead times short. The polymer 3D printed tools are also lighter weight than they would be if they had to be machined out of steel or aluminum, which opens up more capacity for the parts that need to be handled. If the cobot has to deal with a particularly heavy payload, every ounce counts, and it's important to get as much weight as possible out of the end effectors. Using 3D printing to address custom tooling needs like this is not just a win for additive, it's also a win for automation. Easier access to end effectors and other types of automation peripherals makes it faster, easier, and cheaper to integrate automation like this into facilities and into manufacturing processes. For more about how 3D printing and automation goes together, see the links in the video description. And if you're interested in more ways that 3D printing is changing manufacturing, follow Additive Manufacturing Media. Thanks for watching.